Hi, this is Math 2510, and this video is over section 6.4. We're going to look at calculating volumes using what's called a shell method, which is an alternative method to finding the volume. We normally use this when it's not easy to solve for x, and we have to revolve it around the vertical axis, but also going to look at how you would do this around a horizontal axis. You're basically taking kind of like a cylinder and rotating it around. If you look at the area of a cylinder, it's 2 pi r times h, that's the surface area. And if you integrate that, you're integrating the area, you're going to get a volume. And so we're integrating the surface area to get the volume. And if you think about that, the volume of a cylinder is pi r squared times h. And if you were to take the derivative with respect to r, you'll get 2 pi r times h, which is your surface area. Right, so that's where that's coming from. We're just going backwards on this. All right, so we're going to integrate both horizontally and vertically. For the horizontal axis of revolution, you're rotating it around this x-axis. Your limits will go along the y-axis from C to D. So everything we're going to do, we have to have in terms of y. Right? The radius goes from the x-axis to the function, and that's just going to be y. So this we just labeled as y. And our height, each of x is kind of standing for height there, we have to put as f of y. In this case, we'll have f of y be the function. And then, we're basically integrating 2 pi radius times height. For the vertical axis rotation, here we're going around the y-axis. Our height, it goes from the x-axis to the function. And so it's just going to be the regular f of x. And our radius goes from the y-axis to the function, and that's just going to be x. And so we'll have, in general, for these, b equals 2 pi from a to b. A to b is along the x-axis, x f of x dx. And for the vertical, 2 pi from c to d, y f of y dy. All right, so let's go through some examples. Here we have y equals x minus 1 times x minus 3 squared. And we're going to graph this about the y-axis. The function is also bounded by the x-axis. So we can get what the graph looks like here. Actually, I want to give myself some space because I want to rotate it around if I can. So 0 points are 1 and 3. If we plug in 2, we will get 1 as well. So the graph looks like this. And so this is the shell we're going to rotate around. And so if you think about it, all these rotate around like this, creating what looks like, I don't know, kind of cake in a way. I'll draw this 3D too. That didn't work out as well. but it creates kind of, I don't know, half a donut or Bunsen cake or something like that kind of shape. All right, so the integral be 2 pi from c to d. We're doing this about the y-axis. So our limits will be along the x. So it's going to go from 1 to 3. And then we're going to have x be our radius. And our function is going to be f of x, which is just x minus 1, x minus 3 squared dx. Again, y-axis, vertical axis rotation, it's just f of x. Now, we're going to want to FOIL this out and get a whole polynomial strand that we can do. So we'll do 2 pi, limit to 1 to 3, x squared minus x. And this will be x squared minus 6x plus 9 dx. And then FOIL that out. We get x to the 4th. And then we'll have a negative x cubed and negative 6x cubed. So it'll be negative 7x cubed. And then you'll have, let's see, and negative 6x squared and 9. Oh, actually, no, that'd be positive 6x squared and 9x squared would be 15x squared. And then a negative 9x. And again, dx. So we'll integrate 2 pi times x to the 5th over 5 minus 7x to the 4th over 4 plus 5x to the 3rd minus 9 over 2 x squared. And we're integrating this from 1 to 3. Right, so we're going to start by inserting 3. And I'm going to do a little bit of the math. So 3 to the 5th is 243. So I have 243 over 5 minus 3 to the 4th times 7, which is 567 over 4. 3 to the 3rd is 27 times 5 is 135. Then that'd be 3 squared is 9 times 9 is 81. 2. That and minus 1/5 minus 7/4 plus 5 minus 9/2. And then I'm going to distribute the negative sign, so I'm not worrying about that. So that makes that plus and minus plus minus plus. Now we can put this together. 243 over 5 minus 1/5 is 242 over 5. Negative 167 plus 7 will be negative 560 over 4, which is 140. 135 and negative 5 would be 130. And then negative 81 plus 9 would be 72 over 2, which is negative 36. So 242 divided by 5 is 48.4 minus 140 plus 130 minus 36. You get 2.4. You get 4.8 pi or 15.1. Okay. Really, getting the integral set up is the most important part, and then it's just integrating it, and you have to be careful with that because anywhere in this you can make a mistake. All right, so the next one, we'll graph this. So this is going to be 1, 8, 2. So we're looking at y equals x to the 1/3 power. So be 0, 1, and 2 is 8. I'm graphing wrong. Hold on a second. Graphing count backwards. That again. 1, 2, 3, 4, 5, 6, 7, 8. A is going in for x. All right, so 1 is 1, 0, 0, A is 2. So this is what we look at. That's x equals 8. If we have our x-axis, this is the shell we're rotating across the x-axis. And so it becomes kind of like a sideways bell. Not that strong, but looks like that. Being rounded out. Well, kind of like a bullet, I guess. All right, so let's set the integral. All right, we're doing it across the x-axis, so we'll be dealing with y. So y, and then this would be, if we solve this for x, y cubed equals x. dy, 2 pi out in front. And then the limits are along your, this is horizontal, your limits are along your y. So we'll go 0 to 2. And so this becomes 2 pi integral from 0 to 2 of y to the 4th dy. That becomes 2 pi y to the 5th over 5. Integrated from 0 to 2. 0 is not going to do anything. It's just going to be 0, so we don't have to worry about the bottom limit. We get 2 pi 2 to the 5th over 5, which is 2 pi 32 over 5, which is 64 pi over 5. I'm actually fine if we keep it like this. Or if we wanted to, this is 12.8 pi. It could be written like that, or we can just get a decimal. And you get 40.2. That's volumes by shells. All right, the last section we'll get into is 7.5. I'll do this in another video. I'll see you then. Bye.